Hello everyone, welcome back to my channel Explain Maths. Now in this video I am going to give a complete explanation of the trigonometric ratios of different angles like 0 degree, 45 degree, 30 degree, 60 degree and 90 degree. So first I am going to begin with trigonometric ratios of 45 degree. So first of all I am going to find the trigonometric ratios of 45 degree. So for that I have taken a triangle ABC, right angle at B. And I'm assuming that my one of the angle is 45 degree. Then only I can find the trigonometric ratios of 45 degree. So I have assumed my angle A is 45 degree. Then how to find the measure of angle C? Angle B is 90 degree, angle A is 45 degree. And we already know one of the property of a triangle is the sum of the three angle is always 180 degree. So using that property I can find the value of angle C. Isn't it? So angle C will be 180 degree minus sum of 90 degree and 45 degree. And if I calculate it, I will get the measure of angle C as 45 degree. And I have used angle sum property of the triangle. So from here I can write angle A is equal to angle C, isn't it? And we have also studied that in a triangle chapter in lower grade that if two angles are equal, then the side opposite to equal angle will also be equal. So for angle A, the opposite side is BC. For angle C, the opposite side is AB. So from here I can write BC will be equal to AB, isn't it? And what is the property? Side opposite to equal angles are equal, isn't it? So BC and AB both are equal. Now, if both are equal, let me assume these equal sides as A. Okay, so I assume both as A because if I take BC as A, obviously AB will also become A because both are equal. Now, I can find the value of AC, isn't it? So AC, how will I find? Again, we have to use Pythagoras theorem. So by Pythagoras theorem, which tells that the square of the hypotenuse, which is AC square, will be equal to AB square plus BC square, isn't it? And AB square will be A square, BC is also A square. So A square plus A square is 2A square. So AC square is 2A square. So the value of AC will be root of 2A square, which will give me the value of A root 2. So from here I got the value of AC as A root 2, isn't it? Now let's find the value of sine 45 degree, cos 45 degree because now I have all the values over here, isn't it? So now I am going to find the value of sine 45, cos 45, tan 45. Okay, all the six trigonometric ratios I am going to find. But for that, first let me mark it. If I am finding angle A is also 45 degree here, if so with respect to angle A, which is my opposite side, which is my adjacent side, which is the hypotenuse, let me mark it, then it will be easy for me to do. Okay, so from here you can see this is a right angle, so opposite to right angle the side is hypotenuse, so here AC is the hypotenuse. Then BC is the opposite side of angle A. So for angle A, the opposite side is BC and the adjacent side is AB, isn't it? Now I am going to find all the trigonometric ratios. So let me start with sine 45 degree. Okay, so sine 45 degree is opposite by hypotenuse, isn't it? Opposite is A and hypotenuse is A root 2. So A cancel, I will get it as 1 by root 2. Now let's find cos 45 degree. So cos 45 degree is adjacent by hypotenuse. And what is your adjacent? A. A by A root 2. So A cancel, it will give you 1 by root 2. Next is tan 45 degree. Okay, so tan 45 degree is opposite by adjacent. So your opposite is A, adjacent is also A, so A by A will give you 1. Now once you get the trigonometric ratios of sine, cos and tan, the other three trigonometric ratios also you can easily find out because they are the reciprocal of these. So let's keep it all in one table. So from here we can see sine 45 degree is 1 by root 2, which I have found over here. Cos 45 is also 1 by root 2. Tan 45 is 1. Now cosec 45 degree is the reciprocal of sine 45 degree. So reciprocal of 1 by root 2 is root 2. Same way sec 45 degree is the reciprocal of cos 45 degree. So again reciprocal of 1 by root 2 is root 2. And cot 45 degree is the reciprocal of tan 45 degree. And reciprocal of 1 is 1. So this is all the trigonometric, 6 trigonometric ratios of 45 degree. So hope it is now clear to everyone. Now next I am going to find the trigonometric ratios of 30 degree and 60 degree. Okay, so now I am going to find the trigonometric ratios of 30 degree. So here I have taken ABC as an equilateral triangle. Okay, so ABC is an equilateral triangle, and we know that in an equilateral triangle all the three sides are equal measure as well as all the three angles are also of equal measure, which is 60 degree, isn't it? Then only 60 plus 60 plus 60 will give me 180 degree. So in an equilateral triangle all the three sides are equal as well as all the three angles are also equal. Now I am going to draw a perpendicular AD from A to the side BC. So this is the perpendicular I have drawn. It means now this is my 90 degree. Okay, this is also 90 degree. This angle is 60 degree. This is also 60 degree. And my angle A completely is also 60 degree, which I am not writing it as of now. Now next I am going to take two triangles. Okay, when I drop the perpendicular, now the equilateral triangle is getting divided in two equal triangles, isn't it? Not two equal triangle, it is getting divided in two triangles, ADB and ADC. Okay, now in triangle ABD and ACD, now what are the three pairs which are equal? So first I can write AB will be equal to AC, isn't it? As ABC is an equilateral triangle, all the three sides will be equal to each other. So AB will be equal to AC. Next, angle ADB and ADC will be 90 because I have already written here, I have drawn perpendicular AD from A to the side BC, isn't it? Now third one is AD is the common side in both the triangle. So by this I can say that both the triangles are congruent. So triangle ABD is congruent to triangle ACD. Now what will be the criteria? So you can see both the triangles are right angle triangle and AB and AC will be the hypotenuse. So can I say the both the triangles will be congruent using RHS criteria? Isn't it? Now if two triangles are congruent, then we know that their corresponding part will also be equal. So from there I can write BD will be equal to CD. The corresponding side of BD is CD. So BD will be equal to CD and angle BAD. Okay, this angle BAD will be equal to angle CAD. Okay, so this is by CPCT. Now, this complete angle A was 60 degree, isn't it? This complete was 60 degree. Now it is getting divided in two equal parts, means this is 30 degree and this will be also 30 degree, isn't it? Now what I am going to assume? I am going to assume the side of the equilateral triangle as 2A. So let us assume AB is 2A. So if this is 2A, AC will also be 2A because it is an equilateral triangle. BC will also be 2A. So BD and CD both are equal. It means this will be A and this will be also A, isn't it? So if I take triangle ADB, if I take triangle ADB, I know the value for AB is 2A, which is the hypotenuse. BD is A. So by using Pythagoras theorem, I can find the measure of AD square. So AD square will be AB square minus BD square, isn't it? And AB square is 2A whole square minus A square. 2A whole square means 4A square minus A square. So from here I will get AD square as 3A square. So if AD square is 3A square, the value of AD will be root of 3A square, which will give me the answer as A root 3, isn't it? So my AD is A root 3. Now let's find the value for trigonometric ratios for 30 degree. Okay, so sine 30 degree. So if you see 30 degree, the opposite side is BD. So this is the opposite side. AD will be the adjacent side and this will be the hypotenuse, isn't it? It is very important to mark these before writing the trigonometric ratios. Now sine 30 degree is opposite by hypotenuse. So opposite is A, hypotenuse is 2A. So sine 30 degree will be 1 by 2. Okay, now next find cos 30 degree. So cos 30 degree will be equal to adjacent by hypotenuse. So adjacent is A root 3 and hypotenuse is 2A. Again A cancel, it will be root 3 by 2. And tan 30 degree will be opposite by adjacent. So which will give me the value as opposite is A, adjacent is A root 3. So A cancel, I will get 1 by root 3, isn't it? And then cosine is reciprocal of sine. So it will be 2. 1 by 2 reciprocal is 2. Sec 30 degree is the reciprocal of cos 30 degree. So it will be 2 by root 3. And cot 30 degree is the reciprocal of tan 30 degree. So which is reciprocal of 1 by root 3 is root 3. So these are my all the 6 trigonometric ratios for 30 degree. Okay, now I'm going to show it in one table clearly. Okay, and then I will move to trigonometric ratios of 60 degree. Now 60 degree also you have to find using this method only. So 60 degree is here. Now with respect to 60 degree you have to find which is the opposite angle, which is the adjacent angle, which is the hypotenuse, and using this only. Using this triangle only I am going to find all the trigonometric ratios of 60 degree. Okay. Now I have summarized the trigonometric ratios of 30 degree in this table. So sine 30 degree is 1 by 2, cos 30 degree is root 3 by 2, tan 30 degree is 1 by root 3, cos 30 degree is the reciprocal of sine 30 degree. So reciprocal of 1 by 2 is 2. Sec 30 degree is reciprocal of cos 30 degree. So reciprocal of root 3 by 2 is 2 by root 3. And cot 30 degree is the reciprocal of tan 30 degree. So reciprocal of 1 by root 3 is root 3. Okay, so now trigonometric ratios of 60 degree. So now it is a continuation of 30 degree which I have done. Again I have taken ABC as an equilateral triangle. Okay, and from point A you have to drop the perpendicular AD. And as I have already proved that these two triangles are congruent, and by CPCT I have written BD equal to DC and this angle BAD is equal to angle CAD. This much we have already done, right? This is 90 degree, this is 60 degree, this is 30 degree, because by CPCT I have written angle BAD is equal to angle CAD. And I assume the sides of the equilateral triangle as 2A. So AB is 2A. BD and CD are equal, so BD will be A, and by Pythagoras theorem we have already found the value of AD as A root 3, isn't it? Now with respect to 60 degree, your opposite side is AD, adjacent side is BD, and AB is the hypotenuse, isn't it? Now I've written in the short. Let's find the each trigonometric ratios with respect to sine 60 degree. The sine 60 degree will be opposite by hypotenuse. Opposite is A root 3 and hypotenuse is 2A. So A cancel, it will be root 3 by 2. Now cos 60 degree is adjacent by hypotenuse. Now your adjacent is A and hypotenuse is 2A. A cancel, the value is 1 by 2. Tan 60 degree is opposite by adjacent. So it will be A root 3 by A. So it is root 3. And once you get the value of sine, cos and tan, you will get the value of cosec, sec and cot also. So cosec 60 degree will be the reciprocal of sine 60. So it will be 2 by root 3. Same way sec 60 degree will be reciprocal of cos 60 degree, which is 2 by 1. So it is 2. And cot 60 degree is the reciprocal of tan 60 degree. So reciprocal of root 3. Root 3 means it is root 3 by 1. So reciprocal is 1 by root 3. So I have arranged everything in the table form. So you can see sine 60 degree is root 3 by 2, cos 60 degree is 1 by 2, tan 60 is root 3, cosec 60 is 2 by root 3, sec 60 is 2 and cot 60 degree is 1 by root 3. So this is the trigonometric ratios of 60 degree. Now next I am going to do the trigonometric ratios of 0 degree and 90 degree. Okay, next I am going to do the trigonometric ratios of 0 degree. So again I have taken a right angle triangle ABC, which is right angle at point B. Okay, so here if you see, you have to find the trigonometric ratio of 0 degree. So if here angle A I have taken, if I am reducing this angle A to 0, then what will happen with the side BC and AC? If this angle I will decrease, then you can see slowly this BC will also decreasing and AC will become close to AB. So you can see when I am decreasing, what is happening? The length of BC is decreasing and AC is also moving down, and slowly what will happen when the angle A will become equal to 0. Here you can see angle A is equal to 0. Then AB and AC both are same. AB and AC both will become same and BC will reduce to 0. The length of the height of BC will become 0 over here. So what is happening when the angle A gets smaller and smaller, the length of the side BC decreases and the point C gets closer to point B, isn't it? Point C will become closer to point B, and finally when angle A becomes close to 0, AC will become almost same as AB, isn't it? It means when angle A is 0, okay, when angle A is 0, then BC will become 0 because the height will become completely 0 and AC will become equal to AB. Okay, now let's find the all the trigonometric ratios with respect to 0 degree. So if this was my original triangle, so this is my hypotenuse. Okay, with respect to A, this is the opposite side and this is the adjacent side, isn't it? So if I have to find sine 0 degree, so it is opposite by hypotenuse and opposite is BC, BC by AC. So when my angle A is 0, BC I have written it will be 0. Okay, and 0 by AC will be 0 only. Now same way when you have to find cos 0 degree, it will be adjacent by hypotenuse. And adjacent is your AB, hypotenuse is AC. And when angle A is 0, here I have written AC will be equal to AB. So it will become AB by AB, which is equal to 1. And tan 0 degree, okay, tan 0 degree will be opposite by adjacent. Your opposite is BC by AB and BC will become 0. So 0 by something will be 0 only. And once you get the value of sine, cos and tan, you can get the value of cosec, sec and cot also because they are the reciprocal of that. So I've written everything in the table. So if you can see over here, sine 0 I got the value as 0, cos 0 is 1, tan 0 is again 0. Now cosec 0 degree is the reciprocal of 1 by sine 0. Now 1 by sine 0 means 1 by 0, isn't it? It is 1 by 0 and 1 divided by 0 is not defined. Now sec 0 degree is the reciprocal of cos 0. So cos 0 is 1, reciprocal of 1 is 1. And again cot 0 degree is the reciprocal of tan 0 degree. So tan 0 is 0. So 1 by 0 is again not defined. So these are all the 6 trigonometric ratios of 0 degree. Now last I am going to do the trigonometric ratios of 90 degree. Now next we are going to do trigonometric ratios of 90 degree. So again I have taken a right angle triangle ABC. Here one of the angle is 90 degree. Now you have to find the trigonometric ratio of 90 degree. Now you can see angle A is not a 90 degree angle over here. Okay. So to make it 90 degree, what you have to do? Slowly you have to increase this angle A. And what will happen when you increase the angle A? What is the effect in angle C? So you can see as angle A you are increasing, the angle C is decreasing, isn't it? And when this angle A will become close to angle B, then only it will become 90 degree. And in that case, angle C will become 0 degree. Can you see here, angle A and angle B now both is 90. Then what is happening with angle C? Angle C became 0. And you can see from here, this length AB is keep on decreasing, isn't it? And when angle A become equal to angle B, this AB becomes 0. And this AC becomes equal to BC. Can you see from here? So what is happening? When angle A is made larger and larger till it becomes 90, angle C becomes smaller and smaller. And moreover, the length of the side AB keeps on decreasing. And then at the end, what happens? This side AC coincide with side BC. So what is happening from here? We can conclude from here that when angle A becomes 90, AB becomes 0 because the length of side AB is reducing and it reduced to 0 and AC becomes equal to BC. Okay. Now from the original triangle, if you see with respect to angle A, this is the opposite side, this is the adjacent side and this is the hypotenuse. Okay, I'm writing in short hypotenuse. Now let's find all the ratios. So sine 90 degree will be equal to opposite by hypotenuse. Opposite is BC, BC by AC. And what happens? AC and BC it becomes equal when angle A is 90 degree. So I can write BC as AC. So AC equal to AC which will become equal to 1. Okay. Now cos 90 degree is adjacent by hypotenuse. Now adjacent is AB, AB by AC. And AB what happens when angle A is 90? It becomes 0. So 0 by AC will be equal to 0. And tan 90 degree is opposite by adjacent. And from here you can see your opposite is BC, BC by AB. Now AB becomes equal to 0, isn't it? BC by 0, which means it is not defined. So your tan 90 is not defined. Okay, now I have written everything in the form of table. As you got sine, cos and tan value, you can calculate now cosec, sec and cot value also. So here I have written. So you can see from here sine 90 I got the value as 1, cos 90 is 0, tan 90 is not defined. Now opposite of cosec 90 is reciprocal of sine 90, so reciprocal of 1 is 1. Sec 90 is reciprocal of cos, so reciprocal of 0 means 0 by 1. 0 means it is 0 by 1, so reciprocal will become 1 by 0, isn't it? So 1 by 0 means it is not defined. Okay. Now cot 90 is the reciprocal of tan 90. So 1 by tan 90, 1 by not defined, this will become equal to 0. So from here you can see that I have found all the trigonometric ratios of 90 degree. So that's all for today's class. I hope you all have understood the trigonometric ratios. And if you like my channel, please subscribe to it. That's all for today's class. Thank you.